Well, welcome everybody. If you guys want to grab seats, we'll get started. But super excited that you guys decided to join us today. We'll do some quick introductions and then get on our way.
Jump right into it. So if you'll indulge me for a second, it was back in 99, 2000, where a much younger guy had a small baby, his first kid, and that kid spent an awful lot of time watching Unreal Tournament. So it's pretty darn cool to be here, to be doing this here at Unreal Fest. My name is Kyle Lindsay. I am part of the innovation and transformation team at Worldwide Technology. Our team covers primarily media, entertainment, and gaming, from leading edge technologies, computer vision, digital twins, robotics, simulation, and obviously real-time 3D with Unreal Engine. And really excited to be here today.
My name is Brad Martin, CEO of Another Reality Studio, a consultancy Unreal shop that works in immersive technologies, primarily R&D, rapid prototyping. We work with anybody from startups to Fortune 100 companies, helping to better their product or workflow using the tools of Unreal Engine. So very similarly, remember UDK and the transition to UE4 and now UE5, and it's just so exciting to see the progress and the tools that have been built out from the Epic team to allow us to now talk about this integration with digital twins. And so throughout the 10 years we've been developing applications for business, gaming, media, and entertainment, we've also been building internal tools that help per industry. So we have a couple of platforms. One of those is a digital twin platform built on the backbone of Unreal Engine, which we'll talk about a little bit. But yeah, just great to see, especially in the M&E Executive Summit and the keynote,
Yes.
all the great stuff that are coming for this. So.
Yeah, and I'd like to invite you. We do have a booth downstairs or right across from the AWS booth, so come and visit us. That'd be great.
Yeah, so today we'll talk a little bit about trying to define what a digital twin is and the advantages of real-time 3D data and kind of visualizing that across different various industries. But I also want to ask everybody to drop their guards because I understand that the definition of digital twin, we're all going to have different answers. So I don't expect that this conversation between Kyle and I is meant to be a learning session. This isn't a classroom setting. We're not trying to teach you this is what a digital twin is. We're trying to have this conversation around what we have found to be practical underneath the umbrella of digital twin technologies across the use cases. And so just drop that guard. If I say something that doesn't quite align with you, that's okay. We can still be friends on what a digital twin is.
And I find if you ask 10 different people what a digital twin is, you're going to get 10 different answers. And they're going to be radically different among different industries. We cover everything from pharmaceutical to government to big enterprise to manufacturing. And I can't tell you how many times we'll go into a meeting with a senior executive and they will say, I need a digital twin. I'm like, sounds awesome. What do you mean by a digital twin?
Yeah.
And that proceeds to a very long conversation.
Yeah, I love that. So without further ado, though, I will tell you right now exactly what a digital twin is.
A mind powerful enough to bridge space and time, past and future, who can help us into a better future.
So
that's a digital twin for you.
So no joke, on the airplane, on the way here, just kind of thinking through notes, watching Dune, of course, part 1. And this pops up and I'm just like, yes, that is what a digital twin is. But just kidding. But Lady Jessica Atreides does say that a mind powerful enough to bridge space and time, past and future, who can help us better enter a better future. And I love that, like, we think it's very close now. Like, I just think that's great because there's a lot of technology that Unreal's doing that's helping us there. Also with the Dune Awakening game being announced, built on Unreal Engine, just super cool thing to kind of combine that, which is a lot of the stuff that we've talked about. If you want to kind of jump into some of that industry specific stuff.
Yeah, so I really liked what Kim talked about at the M&E Executive Summit earlier, right? The transmedia. Mm-hmm. And I think that really comes into play with digital twins because you have these assets that are reusable, right? They're reusable between a training environment to ad tech to MarTech, all the way through to IP, games, content. It really is, we're to the point now where we have this set of assets that we can use across a multitude of different use cases.
Yeah. Kyle, you want to start with yours?
Yeah, so I can jump in. Like I said, so we have a lot of conversations across a lot of different verticals. And the question comes up of what is a digital twin? How can I build a digital twin? What does it look like? So we've put some time into thinking through big buckets. And we've kind of come up with these 3 different buckets that seem to work pretty well. It's not perfect. It doesn't work all the time. So starting in with data, right? We have done a lot of data digital twins. We worked with a NASCAR team to build out a data digital twin of a race car. It had 0 visualization. So there was no cool graphics. You're not going to drive it. It was strictly a dashboard and a bunch of data points off of a giant database. So we do have these conversations of you can have a digital twin that has no visualization really aspect to it. Then we kind of branch out from there to systems. So this is kind of connecting different sets of data. A good example recently is working with a large telecom, looking at their radio access network. So actually Seattle was one of the areas we looked at of the radio propagation going between the buildings in a downtown area. Created a digital twin for that type of an application. And then obviously we've gotten to the experiential, what we do here, real-time 3D, Unreal Engine, being able to lever that. The magic comes in actually is when you connect the 3. We're finding that people will start at various points in their journey, but when we can tie them all together, get the data feeds into the systems, and finally be able to have a visualization, a real-time 3D visualization, that's really where the magic happens.
Yeah, and partnering with Worldwide Technology over the past couple of years, that's something that is very obvious. They're world-class leaders in how they can take data systems and tie them together into something that's usable for your company. And so it's been awesome partnering with you on that. Similarly, for some of the stuff that we've done in the digital twin realm is we've been focusing on a few things that we like to add into our digital twin applications. Now, my background is in architecture and built space. It's what I studied. Set up a couple of immersive labs in our university and across 3 different universities and nonprofits, and where we're based out of St. Louis. And we have, I have specifically studied the built space and architecture, so my mind oftentimes goes to that industry. And I like to think of GIS and architecture as kind of a ground foundation for any digital twin, whether that be in robotics or whether that be in simulation, really understanding and grounding it to a real world location. So with geospatial anchoring, I would say that it's not really optional. It's something that's essential to really understanding how your twin is going to interact in that space. Think about physics, think about ecosystems, think about all of these things that are different based on where you're at. So I would say that geospatial anchoring is something that we try to tie into all of our twins. Also integrated operations, coming from the built space, we try to tie in as much sensors, IoT, and work across architecture as we can so we can better understand that space. That's something that's really important in the digital twin and what it can project for us, what data it can tell us, and how you can control this building, even from not being there, and really trying to help that efficiencies. And then spatial cognition would be my last one. I think there's a lot of stuff, a lot of data, a lot of interesting information that is within a location that you can't see. So visual aspects of a digital twin are great, but what happens behind this wall if you're in the physical location? What happens within the inner workings of robotics? Having that data communication back and forth and understanding spatially where that's happening within your product or space is so important with a digital twin. So I guess a quick sum up from all of our conversation here would be physical, virtual, or digital, and a communication between the two. Yep. Let's just sum it up like that.
So if you look at the evolution of digital twins really became a hot button topic. It seems like within the last probably 8 years, 9 years, where you actually see a lot of 10Ks, 10Qs, companies talking about having digital twin plans across various enterprises. But really, if you can go all the way back to the 60s, right? Some of the original digital twin work was actually done by NASA as part of the Apollo program. So there's not a lot of like really new concepts. It's just we've gotten to the point where the tools have caught up to what we've wanted to do all along.
Yeah. Yeah, and I think, again, exactly on that part, like where these technologies have been developed and how it crosses over to AEC is kind of where my mind likes to live. But I just jotted down, and I won't read through this whole list, just all these technologies of what used to happen from hand drafting down to BIM, and now getting into how IoT and how these different, cloud computing, edge computing, and AI can help us. Good thing we're not describing AI in this, because that's
that could
a whole
be
other
rough.
level. We'll stay away from that for now. Just talk about the digital twins. But this is just a list of kind of brainstorming, kind of what technologies have evolved into digital twin capabilities of what we're doing now.
Yeah, so it's interesting. So we've been doing this a long time, right? And the technology has finally caught up. The GPUs, the power of Unreal Engine, the powers of our IoT systems. Interesting enough, what we find is it's not really a technical challenge more often than not. A lot of these challenges are organizationally and governance. So I mentioned earlier that we will go into meetings with executives of various companies, and they'll say, I want a digital twin, whether it be a frontline director or whether it be a C-level. That definition of a digital twin changes radically throughout an organization, let alone between the slices of an organization. Part of our role at WWT is a translator. It's really to help the communication. So the theme is practical digital twins. How do we actually build these things? Like I said, a lot of it's not the tech. A lot of it is just getting people to talk to one another, getting organizations to agree with one another of what their definition of a digital twin is. And another important thing here is start small. We have a lot of customers who are very ambitious with their plans to build out digital twins. And we always encourage, let's start small. Let's start with a small little MVP effort. Something very constrained with a small team. Start out with a proof of concept, move to a proof of value. We've seen a lot of success as opposed to going and then diving in full bore with this massive plan to build out these digital twins. Starting small, we've seen a lot of success with.
Yeah, and throughout that communication, like that solving so many things, I remember being in a lot of workshops with clients as we're going through with them and just trying to understand the who owns it portion of that. It's just massive. So really understanding how they can be used and getting into that strategic planning session with your client or with your product, if you're doing this internally, is so important to think through not only what can be done, which we're going to get into now that we've talked about some obstacles, but how to do it. And so here's a very specific issue that we run into. Obviously, with digital twins, you run into massive loads of data. A lot of like built projects, if you're talking about a skyscraper, generally the paperwork that you have to sift through is 3 times the size of that skyscraper. It's just all this information that's coming in from plans to specifications to historical, addenda, change order, everything that's coming into us, we have to organize. And so one very specific solution is how do we do that? What challenges are we running into? And then how do we keep that space and coordinate across different companies and different documents? So what we've done is we've taken CAD objects. This is a very specific project for architecture. We took these CAD objects, we exported them to a text file, giving them a very unique ID while keeping the metadata tied to that unique ID. Then we imported that into a 3ds Max using a custom script that's going to basically create that object and tie back together based on that text file back to the coordinates, all this information that goes in that single place. After that, we imported into Unreal using Datasmith, which Datasmith is a fantastic tool. It does keep that non-destructive connection to a lot of the metadata that you can do there and you can tie it into, and it's extremely quick. And then lastly, you can see on the bottom picture, this is interesting, we had to hide everything else, but you can see all of those data points by unique ID spanned across a spatial location now. including not just the X and Y, but we do have Z data in there as well. This one's I've cut out a lot of stuff, so it's showing mostly on the 2D, but you can see all this data now starting to have a specific point, which is so important when you're talking about digital twin and a spatial representation. So now, what's new and what's changed? So we just talked about history, evolution, some things that we ran into obstacles, but now we're talking about this new technology that Unreal is offering us that brings into this new realm of digital twins that we can use. So I don't know if you guys were here last year, but Hannes Walter talked from Black Shark about digital twin based on the earthquake that happened in Turkey. It was a really interesting talk. They were able to identify, just based off the past data, which we talked about bridging over space and time, but the past data of what buildings used to be, now what buildings are no longer there, and kind of focusing that effort on where to search, where to send these teams. And that's something that as you have this data connected, you can do. That's that real-time data integration that's so important.
It was such a good example.
Oh, yeah.
That was the one that really stuck with me as well. I usually get involved in digital twin conversations from an excited forefront, like new products, new development, new streams of revenue. But having that of rescue workers, there was a building here, now there's not a building there. That was a great example of digital twins for me.
Yeah, and then the complex systems that we've talked about and that automation into there, plus all of the hardware advances that you're seeing. I think some of the most exciting stuff that Bill Clifford talked about in the keynote yesterday, at least for me, is some of the improvements coming to nanite and some of the megalights. I don't know if I saw that, but I'm like super jazzed about megalights now, and you'll see why here in just a minute.
Yeah, I was gonna say, so when we saw megalights, we were like, oh, wow, we wish we had this about a year ago.
Yeah. So some of the tools of transformation that are happening in Unreal, we've talked about Datasmith a little bit, but you can do a lot with blueprints. I think a lot of times they can get discounted in larger projects like this, but automating that scripting to place this stuff is something that was greatly helpful to us. And then live linking to different construction programs and live linking to different things there that can help kind of keep that real-time data. It's not just about getting that real-time data and seeing what's going on, but it's about projecting that data into what might happen as well, which we'll hit on in a couple of our case studies next. But if you look at this background picture, this is a city for entertainment that we are mapping every single light and much more data, but light's very easy to talk to you guys about. It's a very visual thing, obviously, so you guys can see what we're doing here, but there's over, if we had to guess, we actually don't know the exact number.
We don't know. This is a guess.
Yeah, but over 1 million LED points that are fully controllable by DMX that you can now control this city and kind of understand not just mapping out and scheduling, but what it's going to look like in that space and what the efficiencies are going to be, all the data that comes through that utility as well.
Well, and I think an important part of this, right? So we're guessing 1 million, and every single LED controllable, right? That is scale. So that is a big thing that we're finally getting to, where we could do small scale digital twins, but when you start talking about these large scale, we are finally here now.
Yeah, and you have to have that automated scripting to place this stuff.
Yes.
Challenge all of you to do this manually. Talk about some case studies. You want to start with one, Kyle?
Yeah, do you want to click through?
Yeah. Let's do this one.
Yeah, so when you think of digital twins, I think a lot of people think of like either buildings or theme parks or something very physical that people walk into and walk around, a restaurant, you name it. We actually have had a very interesting project where we have created a digital twin of the Remus. And the purpose for this and why we got involved in this was the Navy lost 2 of these. So these are unmanned underwater vehicles. They're very expensive. So when you lose a couple of them, that really told them that they need to get into the deeper simulation. So we worked with them on computational fluid dynamics and doing the models for the littoral AOR area of responsibility. So from 50 feet down to 250 feet. And it was quite a successful project with them. So once again, this is a a entity within water, obviously. So it's not buildings, right? It's not theme parks. So I challenge everybody to make sure that you're thinking outside of the box when you think of what could be a digital twin.
Yeah, absolutely. And I think, do you want to say anything on this slide before?
No, you can go.
Okay. We have a couple of slides here. I think another part when we're talking about full-on space and community development here is not just the construction, the other data, the robotics that are on that site. It's about when you're building that space, checking it against the real world too. And so this is a really good video. I think we have a video here.
So this is Hampton University. Hampton University is a historically black college back east. And they worked with us to build a digital twin. So this is a city-scale digital twin. 84 buildings, approximately 300 acres of land. We did photogrammetry on all of the buildings to OBJ. It was actually 3 days of drone flights to get these images, doing LiDAR scans. And the plan is, now that we've gotten this far, we're actually going to go indoors next. So the goal is to have indoor, outdoor, full digital twin of the entire campus, both above ground and below ground. So when you start thinking about the water pipes, all of the underground facilities to it, they will have a complete model of every aspect of their entire campus.
Mm-hmm. Yeah. And so this is a point cloud running in Unreal Engine. Thank you to the Epic team for making that a lot easier to do now. Very optimized. It's a great way to pull in real world data and then compare it to construction documents, construction models, BIM models, especially on the subterranean side like Kyle's talking about. I think you can probably imagine the difference of a built space that's already around for years and years versus something that's new construction. I'll pop back at another demo here real quick. This kind of will have text over. Oops, got to get used to that. Got to hit it once. We're working on a new development with a good development group out of St. Louis, Missouri, where we're located. So this is all of the Revit files and Rhino files of the entire master plan with real construction plans built within them, running through our platform called Looking Glass that's helping them to not only visualize, but to start planning those operations around utilities. So again, getting back into how do you connect that data, how do you optimize that data, clean that data, make sure it's real time is a lot of the practical use cases that we're finding are helping our developer. But also the things that you have to plan ahead of time. Luckily, Gateway South is what this hub is called, is for advanced manufacturing, and the developers in good development are extremely excited about possibilities of what we can bring to them on the data level and how they can start to really understand not just what energy is being used. We're trying to be net zero here. But also which suite is using the most energy, and trying to think through kind of all the different advancements we can do from a leasing side, from a utility side, from a planning side. So now as we go through construction, having that subterranean data, having the new construction documents, we can start to compare that with construction as it goes through these LiDAR scans. So we can scan once a week on the site. We can import that in through our model in Datasmith, and then we can run a comparison between what does the construction documents have versus what is really being built out there, and start to see where they're off, where we're behind. If you've heard of 4D on construction, it talks a lot about scheduling and where different large equipment will be during the planning and development of these spaces. So being able to see that picture and being able to see where we're off will only offer us a better savings for our client and better timeline for our client. So.
Yeah, and there's some interesting statistics of, here, I even wrote some of them down, right? So 10% cost savings in construction, reduced project delays by 30%, 20% increase in energy efficiency, 20% lower maintenance costs. So you get into real material possibilities and advancements of savings and speed, right? Time is money.
Absolutely.
With these digital twins. And I don't come from an AEC background like Brad, but another interesting data point that we've come across with some of our projects is actually the reliability of the source data, the source Revit, the source BIM, as you're building out these digital twins. I'm always surprised that the difference between what's supposed to be the final paper, the final designs, versus what's going to be built.
Yeah, absolutely. And our data is right in line together with Kyle on saving between 12 to 18%, depending on project side, of costs based on just change order and addenda costs. So it's massive when you have not just visualization, but understanding lead times and kind of what everything is going to be built on a schedule, so how we can optimize that schedule and make it efficient. So it's a really useful tool in the AEC. And we'll go to this next. Okay, so this is a really fun one.
This is a good one.
You want to chat about it?
So once again, we work with multiple entertainment venues. This is a pretty big one, and it's a lighting exercise, right? So it's a way to, as a venue is being built, to test the lights, to do previs on lights, to figure out what it looks like for a Halloween, what it looks like for a Christmas. And it's pretty big.
Yeah. And so this is what we're demoing right here in this video is the true connection. We're using SACN. It does work with other DMX protocols. But what we're showing right now is actual control of individual LEDs across the entire space. So a lot of times in our testing, to make sure they're consequential, we'll send a colored rainbow light down the line. Why not? It's easy to do in DMX and it looks really cool. But we're doing our testing data on response time. We're doing testing data on control based off those unique IDs and what that metadata is pulling in. And then consequentially, when you have a digital twin, and one of the practical use cases of this is you can understand your energy usage. You can understand based on the designs that you're pulling off, what is that doing to utilities, to cost, and does it make sense to lower some of these across the different spaces that are not as active during certain parts of the day? So when you start to layer in pedestrian traffic, open hours, and car traffic, all of these things, you can start to get that data that's like, hey, you've been running these lights on for hours that nobody's there. It's not really useful. And you can kind of cut back on this. But now we have that data where we can give real ROI, and you guys probably all know how important that is when you're talking about developing systems for clients. But really fun video there. We also have a couple, we may as well go through these, a couple of videos here that just show us controlling more lights than just a single instance. So as you go through our automated paths, we did have to blur some of this stuff out. Apologies for it's not the rendering. Unreal's awesome. It's not the rendering capabilities. We blurred this out intentionally.
We did it intentionally.
Yeah, to not give away some of our clients' IP and information. But it's a great, I don't even know how big this is acres wise, but this thing is massive, and we have so many lights, and you can see this. You can even imagine, I'm sure, all these ideas of what you can do in a space like this that's not just based on lighting, but the lighting's a really fun one to show.
No, and what's really cool is, so this was a lighting exercise at its core, but once people started seeing it, then you start getting other people engaged and starting to think of, okay, we've built the model, we have it in Unreal, we have all the materials, now what else could we use it for? And we're kind of at that stage of, hey, we could use it for Q theory of where people are going to go and go and get a beer, go and get a hot dog, right? We can start using it for several other use cases.
Yeah. So a lot of the stuff that we're working on as well, alongside of not just AEC, but even using these places, as I mentioned before, it's like once you have the location. If you spanned out here, you'd see cesium, you'd see Google Map 3D tiles, you could see the full city and the full traffic around that city because these data is tied in. One thing that Mauricio's our CTO, we were joking about on the way here as well, is having digital twins within digital twins within digital twins. So if you guys want a new key term, we're going to call it symbiotic cities or sim cities. So you guys can use that as well. Just getting in the game vibes here, right? So, but anyways, a lot of the stuff that we're doing, light's very visual and easy to see, but just think about other utilities and thinking about what you can do to projections on how people are using your space, whether that's an office or a full city. When you get into some of the smart cities, like things that are happening overseas mostly, but you get into some of those analytics on natural disasters and response teams and how to help those paths and efficiencies. You're not just talking about saving money, but you're talking about saving lives. You're talking about better training. So it's just, we'll see this convergence. This is something Kyle and I were talking about the other day. Mm-hmm. We'll see this convergence of industries that are starting to use the same tools. Right now, everything is very siloed into vertical industries. This is a horizontal tool. We'll start to see horizontal use cases between industries even more tied together. So if you want to add to that, feel free. But
no. That's exactly right. It's an exciting time to be doing this.
Yeah, it really is. Let's go to the next one. So another example, I'll get off the AEC for a second, but when we're talking about device agnostic types of experiences through a digital twin, we wanted to show some immersive capabilities here. So this is a VR experience. So if you get nauseous just from watching, turn your head. It is very jittery. Have you guys ever tried, okay, I won't ask that question, but have you ever tried to film a VR experience when you're in it? You feel like you're moving like this. And this is what comes out, just this like nonstop head jitter. But anyways, this is a manufacturing line for Pfizer, actual digital twin based on the documents and kind of how they create whatever's being created on this manufacturing line, and actually showing a training experience of somebody running through, and we're tracking efficiencies. Again, let me go back one more time. We're tracking efficiencies of how they're able to run through certain steps. This is a 18-step training experience. And we can run through without having to, this is a clean room. I don't remember the level, but you have to get into all the garb. And so getting in there and it takes time. You have to be on site. This is now in VR where they can do that, and we can still experience efficiencies and timing based on how you would actually interact with this machine as you use it and what you need to do. All while sort of training muscle memory in a degree too, so you know the steps better. So you can train off-site. It's really an interesting use case for digital twin. And again, I'm using that a little cavalier, but we're transferring data back and forth for efficiencies. So if you question me on the digital twin thing, I'll probably agree with you.
We're using the word again, and once again, nobody's going to agree on the terms.
Yeah.
And we just recently got involved in a conversation with a big pharmaceutical company, and losing unmanned underwater vehicles is a big deal. This pharmaceutical company actually had a $250,000 centrifuge that they use for making drugs. They had a early in career person break it. So that was another really good use case. So they came to us to create a training environment of this centrifuge because they didn't want any more of their $250,000 centrifuges broken. Can't blame them.
Can't blame them. Design's a fun one. I think getting into costs, and this is for automotive, as you can see, but getting into the different cost differences as you change up different components and some of those lead times, as well as choosing different options, a really fun way to go through the digital twin. If you saw the keynote, you saw BMW, you saw how they're using digital twins from every single nut and bolt within that car and being able to get through it. Awesome demo. And just kind of, I think you can kind of think about how the automotive industry is using these as well. But we're finding a lot of cost savings in that as well, just from doing these basic projections that are based on their actuals over the past years and tying them into a visual sense. So we can actually call out certain data points within this seat, like the Bose speakers within the seats. We can call a data point out that shows how often that breaks or how often that comes in for repair, strictly based on data and spatially recording that. So we're talking about a lot of future technologies as well. Kyle, if you want to dive into some of those.
Yeah, I mean, obviously the AR VR side of it is really exciting. Seeing the advances. I mean, even just last week, I guess, with Meta, with Orion, the Apple Vision Plus or Apple Vision Pro. So we're not there yet. I've always been a big fan of AR VR. We still have a long way to go, but just seeing the advances in the last couple of years, that's very, very exciting. We actually have been at WWT, we're 8 years now running NVIDIA's Deep Learning Partner of the Year. So we have a very, very deep experience in AI, obviously. We have a $500 million AI proving ground lab. So that's really exciting to start seeing AI, ML, and then also the Gen AI, kind of how all of these things are going to intersect. That's very, very cool.
Yeah. I think again, I won't get too far into some of the AI and old school AI and Gen AI and kind of how they can be combined here, but using those for helping to analyze data and project is obvious a benefit to some of the digital twin stuff that we're doing here. And then the edge computing, partnering with ATC and being able to customize composable data centers through worldwide is amazing. So you can describe that better than I can probably, but a very custom setup for running your application.
So, and actually it's funny because we actually talk about our ATC is part of that AI proving, or the AI proving ground is part of the ATC. So it's about $1 billion lab located in St. Louis, Missouri, and it's a giant playground, right? So anything that you can think of from all your manufacturers are in there, and we use it for bake-offs, we use it for lab as a service, but we kind of talk, that's a digital twin, because you can make a direct representation of your network or your data center within our ATC with partners, NetApp, with Perforce, you name it, right? So it's very cool, but it goes to that point of we should be cautious and contemplative of the definition and how we use the term digital twin, because it can mean nothing and it can mean everything. But that's another example.
Yeah, so I guess in summation on this slide is if you're going to, the practical way to use a digital twin is one, use Unreal Engine, which you guys are all here, so I know you will. But that is what you can integrate into and be able to tie a lot of this data into these spatial items here. And then all of these things we see as future, already being able to dive into some of these things within the digital twin and kind of use that around because of Unreal Engine and their, what they're doing with 5.5 and some of these features that we're seeing here. So we do have, we're a little over, but we have 15 minutes for questions, and we really want to get into some of your specific questions. This is high level. We're talking about kind of some ways that we've used it, but we really want to hear what you guys are doing, what questions you have. They can be basic, they can be extreme. We have people that can answer. Maybe it's not us. We got people.
I was going to say, we got people in here who can help us answer some questions too.
But we will try our best. And really appreciate you guys joining us. We'll leave this up here while we do questions. And if you want to scan for our LinkedIn, feel free. But Mike in the center, form a line.
Thank you so much.
Thank you so much.